going to do a presentation. Thank you.
Hey everyone, how are you doing?
Good, good.
Good? How was the dinner? It is my lunch, but it's a dinner. How was it? Good? You guys are feeling good?
Yep.
Yeah.
Ready to learn a little bit more about data? So initially, little disclaimer, I was planning to do a hands-on approach to this, so we could code together and things like that, but then I talked to Steven. We had, I guess, some logistic issues with providing PCs and things like that. So my approach today is specifically going to be more concept-based, and then I'm going to give you more resources in case you guys like to learn more. Feel free to search online and definitely take a peek at these websites. But basically, I'm going to give you guys a brief introduction about myself. I came to the United States in 2012 to get my master's here in engineering management. Graduated in 2014. Majority of my time was working with my advisor on continuous improvement, Six Sigma, and things like that. And that's sort of where the data thing comes into play, and statistics. How many people have heard of Six Sigma, by the way? Show of hands. All right, perfect. So we're all almost manufacturing, so that's not a foreign term to you guys. So with that background, I went into Niagara Bottling, which is the largest private label water bottle manufacturing company in the United States. And part of the manufacturing department, initially I was hired as a CI analyst, data analyst type of thing, part of the technical training sub-department. So I used to run a lot of data on how much training we offer to our operators, supervisors, and things like that. And the idea was that where the money is going, how much benefit we're getting back. So there was a lot of data, nobody cared about it, it was just sitting somewhere. Most of it was trash anyway, but I spent a lot of time back in the days in Excel to figure out how things are working, how better we can advance our processes, where to spend most of our money, things like that. And little by little, I got more and more and more into data. Initially, started learning more about Tableau, which is like a visualization software. It helps you to visualize your data. The concept is the same as Excel, honestly. It's just more advanced. And then I got into the system department, which is essentially in charge of connecting to all the machines in the plants and acquiring the data and providing to the proper teams. And I was part of that team for 2.5 years before I left, and the idea was that how can we create this state-of-the-art manufacturing called lights out, that everybody leaves, you turn the lights off, and everything works for yourself. So that was what my team was in charge of, and my responsibility mostly was focused on data. How, now that we have the data, what can we do with it, and even if we don't have the data, how can we get the data from the machines? For those of you being in the manufacturing is much more complicated than just a service industry or like a IT industry in terms of acquiring the data itself, because you're talking to the machine, it's not really an API or something like that, so it's hard to communicate with that. And last year, around the same time frame, they put me in charge of data science. So it was a buzzword, it still is. It's been a buzzword for the past 10 years. And we're a little bit behind the hype, but manufacturing is catching up to IT, I guess. So they said, go out, learn what data science is, how we can use it in manufacturing, and pretty much I went out and I figured out a bunch of cool stuff, brought it back to the company, and before I left, I was able to automate one of the processes that we had. We saved over $3 million per year on just one of the raw materials we used in the process. But the idea is that my presentation today is mostly going to be focused on how can you really put these concepts into work based on what you guys are working on, and what are the different concepts underneath data science and machine learning. And I'm going to share with you guys some references, some websites that you can go learn about these stuff at the basic level if you're not that proficient in statistics and things like that. So that's going to be part of my presentation, and then towards the end, I definitely want to give you guys more time to ask me any question you have. I'll be glad to, kind of share my thoughts with you guys. So with that, this was last year before Steelers got kicked out of the playoffs. So that was the playoff year, and it's gone. So yeah, if you want, you can connect with me on LinkedIn. I would love to connect with you guys on LinkedIn. And big data. So this is a big concept, this is a big buzzword nowadays. A lot of people are talking about, especially with the rise of social media and things like that. And most people, what I'm going to do, because I noticed most of us are from manufacturing at least, I'm going to try to talk more in terms of manufacturing forms. But especially for us in manufacturing, it was so strange to see how social media could play a factor in manufacturing. Nobody knew if that data even exists or is valuable for us. And then it goes all the way back to your, not only your social data, your machine data. What are the machines telling you? Where the data goes, honestly. Who cares? Who cleans up the data? Who uses the data? And what are the benefits of using that entire giant, I think Niagara as a whole, when I left, had 32 plants, over 130 lines, fast-speed lines. So every line had 10 machineries, and every machine generated separate data points. So you can only think about how much data we had in the system, or we were failing to capture it in the system. So the idea was that now that all these information exists out there, let's find someone or a group of people who knows or have the knowledge to go out, acquire the data, and then extract some sort of meaningful insight from it. So that was my task last year. And as soon as you get into data, you realize there's these different pillars of big data. It starts on the left-hand side with the volume of the data. We're not talking about like 50 megabytes of data. We're talking about terabytes, even more of gigabytes of data, and that's something that Excel fails to process. So that's why with this concept of big data comes a lot of new skill sets and new knowledge that people have to learn. Coding, Python, RStudio, whichever people prefer. The velocity of the data, for us, we had machineries that could make the fastest 2,600 bottles per minute, and you can assume how much data that machine generates. And we had machines that could make 144 preforms. Preforms are basically the raw material that goes into the blowing process and gives you the bottle. And I think we could make 180 preforms in less than 3-4 seconds. So that's all the data out there, the speed we get the data. A lot of times our databases just ran out of space. We didn't know what to do with it. We just cleared all the past data. We were like, to heck with this. Let's just put in the new data. But the idea was no one was there to use the existing data. And it was just going to waste, and we paid a lot of money to these vendors or third-party vendors to come in and help us gather that data. The other thing was the veracity of the data. When you collect the data, especially from the PLC tags, and these are the programmable logic center of the machine, the data is mostly in binary format, and a lot of times doesn't have any meaning. You don't even know if it's a clear data or clean data, or it's just a bunch of random number in there. So it takes a lot of time to make sure you have a clean data, you have something that is coming from a legit resource, you're not reading a different tag on the machine. Essentially, a machine has large sets of tags, so-called tags, and every tag captures one properties of that process. And we want to make sure we have a huge team of automation engineers just focusing on which tags are we reading, are these tags getting generated correctly, and things like that. And then we had the variety of the data. For most of the data I worked with, it was just number data, continuous format type of data, but our quality team had a lot of vision inspection for basically when you go by these cases of water, we call the size bullseyes. And if these bullseyes are not good, then the pack's going to tear up when you lift these packs. So we had a lot of vision data as well. There's a lot of, when we talk about asset care and condition-based maintenance type of things, especially with the motors, over time when you don't maintain them properly, they start creating these weird behaviors. With the fluctuations on the motor itself and the amount of noise it creates, so you even get audio sound from it, audio data from it. And the idea is that now that I have these different type of data, what can I do with it, and what could be done with it? And at the end is the value. What's the value of capturing all this data? I think our company back then has spent way more than $100 million at least on the infrastructure, without having any purpose. We didn't know why we're capturing a lot of these data. We knew exactly what went into every single product that went out the door. We knew a lot about the process parameters, but nothing was really, getting done. And the idea was that we just thought it was cool to have it because we wanted to be ahead of the industry. Especially our CEO was crazy about lights out manufacturing. So nobody really thought about the application side of it until last year. And it's something to think about because big data for manufacturing specifically, it's something that's hard to digest. And without the plan, if you start just jumping into it, you're definitely gonna, encounter a lot of different obstacles in terms of getting buy-in from upper management and things like that, especially if it's about getting budget for it. So the idea is that, at least for us, to get one project at the smallest scale in one plant done, give it to the leadership, say, hey, this generated whatever, $1 million, whatever, and then see if those guys are willing to put in the extra money into the process. But the value is there. The value is there as long as you're investing into your people, because that's a huge part of it. I think there's a podcast I listen to. I highly encourage you guys to listen to as well. It's called Masters of the Scale. Reid Hoffman is the former CEO of LinkedIn. He's the one who's running the podcast. And he brings in these different CEOs and VPs to talk about their experience, mostly in Silicon Valley. And they talk about creating the talent in-house. And the data science, especially for manufacturing, is one of those areas that nobody really wants to get into manufacturing in the first place because people might say it's boring comparing to like Facebook, Google, all those companies. But having that hardship of hiring people, now you need to turn over and look at the fact that I need to build this talent in-house. How can I do it? So that's something to always think about. All right. Let's see. Perfect. Okay, so Industry 4.0, I don't want to really spend too much time on this. How many people have heard of Industry 2.0 by show of hands, by the way? No? Okay, awesome. So, so Industry 4.0 essentially is all about, so with Industry 3.0, it was all about automation. Like, we have a machine that can do, its same task that a human does at 100x speed, and everyone was like, oh, that's awesome. It started with Ford, with their assembly lines and all those cool stuff. And then with Industry 4.0, it was like, how can we get all this information from all these automated machines and find a better way to optimize the performance? If you're talking about supply chain, how can I optimize the flow of material? Not just material, I think in supply chain we have data flow, we have money flow, as well as the material flow. So all of these stuff in Industry 4.0, it was all about connecting them all together and being able to read the holistic story out of it. And that's what's leading the big data or data science topic in manufacturing with the Industry 4.0. I think the stuff I was researching back in the days, one of the good companies that does this stuff right now is definitely IBM. They do a lot of work with different organizations, either at the consulting or their own manufacturing facility, which everything is fully automated. You get maintenance reports on your tablet or whatever you have. You know exactly when to maintain a machine, which saves a lot of costs. Because for us, it was all about preventive maintenance. And for those of you who doesn't know what the preventive maintenance is, it's kind of like a pre-planned maintenance. You say, I'm going to maintain this machine every 10 days. But you don't know if the machine actually needs maintenance every 10 days. Then one step ahead of it is condition-based maintenance. The machine tells you, I need repair right now, otherwise I'm going to fail. And that's where this Industry 4.0 kind of comes into play. Question? Nope? All right. Turning this off. So, talking to Steven, he said you guys are mostly interested about how this stuff works in supply chain format as well. So that's when you think about the concept of supply chain as a whole, not even taking it to the global stage. It's all about, now you have your manufacturing data, you have your demand planning department that mostly is outward, working with sales and things like that to forecast your demand. You got your warehouse logistics operation, you got your transportation outside. So the idea is that how can I get all these data and do something beneficial with it? Like in terms of supply chain, if I'm talking about logistic warehouse operation, We had plants that was run by forklift drivers and as well as laser guided vehicles. With the laser guided vehicles, everything was programmed. We knew exactly how much these machines are traveling through the plant. With the forklift drivers, we didn't know. The forklift driver might as well just park across the facility and just light up the cigar or something. Nobody could know. But now with these LGVs, we had a way better idea of what's happening inside the warehouse, where the product is located. If you're talking about shelving and stacking products, and especially it's an operator-driven type of operation, the operator most of the time doesn't know where the product is, so it takes a lot of time to stack it and things like that. So with that, we cut a lot of waste time and kind of ties in with the CI and continuous improvement from our operation, making sure everything's done the first time. And looking outward to the forecasting side of things, there's so much cool stuff, especially in regards to social media, and something that not so many companies are looking after is something called the sensitivity analysis, and mostly done on Twitter data. So Twitter gives you a lot of text. Basically, over Twitter, your product sucks, your product's good, you get all that data, and you run these sensitivity analysis. Given the location of the users, you know in what regions of the country you have bad reputation, in what regions you have good reputation, what are you doing in the good regions that are generating that type of feedback. And a lot of these could be fed back to your forecasting, because in a region that you have a good feedback, you're essentially going to have more order coming in. These are some cool stuff that nobody before that really looked at. Or even in terms of water, I think 2 years ago it took over, in terms of sales, took over any other beverages in the United States. And that was a big major kind of health-driven type of fact for people in the United States, that we don't want to spend sugar anymore. And a lot of it was driven by social media and different type of advertisement in regards to your health, maintaining a healthy lifestyle, things like that. So when you think about that aspects, companies right now, they don't sit to the customer, come to them and tell them what to do. They dictate the customer how to behave. And that's the cool thing about big data. That's what excites me as a data enthusiast, to go out there and learn how can I drive the customer as opposed to waiting for them to drive our business. So I'm going to talk a little bit more when we come down to this slide about in regards to the supply chain. But talking about the challenges in the supply chain, at least for us in the realm of bottle manufacturing, I sort of break it down into these three components. First of them was definitely the demand fluctuations. The way we receive our demands, and maybe it works the same for you guys as well, was your customer, could be Costco, could be Kroger, whoever it was, they have their own forecasting department. They generate the forecast. They send that forecast to your forecasting department. Your forecasting department is using that data. So there's like different layers. And by the time it gets down to your production, you're either overmaking or you're undermaking. And it's always the case. And the idea is that, especially with the Industry 4.0 and things like that, why don't we go to the source of the data, which is a point of sales, like having access to Ralph membership cards of the users, like knowing how much water was picked up today. I don't want to learn this a month from now because I'm doing the business today, right? So a lot of these cool ideas came into play. We didn't get a chance to work with any of our customers in terms of getting the point of the sales data, but I know a lot of companies that are doing that. Amazon is a perfect example of that, working with Whole Foods. How many people shop at Whole Foods, by the way? So just recently, if you punch in your Amazon Prime account, they give you discounts. But the good thing is that Amazon team gets a point of sales data, and they can essentially know right at the moment you purchase what you purchased. And how many people have heard of Amazon Go, by the way? No? Okay. So it's essentially, they took over Whole Foods. They wanted to turn Whole Foods into an automated grocery shopping store. And they're I think their prototype stores are in Seattle. They have a bunch of those stores. The idea is that there's no clerk, there's no checkout station, there's nothing. You go into the store, at the entrance, you scan your Amazon Prime account or code, and then you pick up whatever you want, you walk out. So this is automation at its best, right? You see the data right there, and they do stuff to even please you. So you have user-based data. These are user-specific data. If I know John goes to the store and he likes candy, then I'm gonna maybe reduce the price on the candy a little bit for John because I know he's more inclined to picking up that candy, right? Or maybe even when he walks to the store, I can send him a message to say, hey, did you look at our discounts on the candy, so he knows there's a discount going on. But these are personalized type of ads right where you're inside the store, which is pretty awesome. So that's with the demand fluctuations, and there's a lot of different statistical models with machine learning that with the demand, we're doing a lot of regression, because the idea is that, how many people is familiar with the concept of regression, by the way? Show of hands. Okay, all right, perfect. So the idea is that you have some input data, and then your output data is the amount that the customer is ordering. Now you're trying to figure out what are the driving factors of that sales. It could be temperature. For us, it was mainly temperature. Summer months, you know, the sales spikes. It could be a lot of different factors, like when the issue happened at, I forgot, Michigan, was it? Yeah, Flint, Michigan. So our sales went off the roof because everybody wanted clean water. Nobody had it at that region, so it just went up, right? And these are the facts that social media can actually come in and be helpful to your company, because you know right there that there's something going on in Flint, Michigan, and I need to divert the sales all the way up to north. So that's the cool thing about the demand fluctuations, which is a lot of regression. And we at the transportation side, especially with the spiking prices of oil and things like that, how can we reduce down that transportation? There were different ideas kicking in, all the way from cutting distribution centers from the between, so that would save a lot of cost for our customer. It would add a little bit to our bottom lines, but it would spike our sales because everyone was inclined to coming to us. So we called it direct to source. So we went exactly to the store that they needed the product, as opposed to delivering to the distribution centers. But the other idea is that if your truck drivers are using the Google map, maybe there's a better app that you can devise internally in your organization to track all the traffics of all the trailers outside of your company. And that way you know this route has a high traffic, this route has a low traffic, maybe there's an accident on this route. So stuff like that, or how you can manage your transportation in a better way. And also in terms of, like, a lot of companies go to these third-party logistics companies. A lot of them own their own fleets. Once you own your own fleets, you have the advantage of being able to access that data firsthand, as opposed to relying on your vendor. There's always, I guess, a fine line in between to say, which one should I do? And for us, I think we tried it in Seattle, it worked out, and we were really interested in expanding it out. And then we have the asset management. This is the critical part, because we run the machines until they're down for like a month, and then we request a replacement part. It probably takes 2 months to send it from Germany or Italy or France. And the idea was that how much are we spending on these replacement parts? And even if we're having a couple of those parts on hand, we might not use it for 5 years, for 6 years. And where's our money going? I mean, the accounting books, it shows as an asset, so it's not a loss. But we know for a fact it was a loss in terms of not getting the return immediately, right? So we wanted to know how we can reduce down that entire giant inventory of assets, of replacement parts, which for us, I think a department of 150 people was managing that department. Everything was going back to our we had a warehouse that we called it repair center, and they sent the bad parts there, we fixed it, we sent it back to the plant. But all of these costs could be minimized just by knowing if the machine does need any sort of maintenance at a specific time. And the idea was to just go out there, find the proper sensors that we need to, let's say, capture the vibration data from the motor, current data, voltage data, a lot of the things that we know that if the voltage is fluctuating too much or the ampere is fluctuating too much, there might be something wrong with the machine. But the data science and the machine learning comes into play in terms of getting all that data, and you already know the output. Your motor is either failed or it didn't fail. And it's more of a called classification issue, where you're classifying your outputs, whether it's a 0 or a 1. 0 meaning that the motor didn't break, and a 1 is when it broke. So you create this cool algorithm to predict. So as soon as your parameters, or we call it features, which are essentially the input into the models, as soon as the inputs into your model start fluctuating, you get a message from the algorithm to say, I need a maintenance right now or within the next hour, otherwise I'm down for a year, right? So these are just cool stuff that saves a lot of lead time and saves a lot of money on your inventory and supply chain management costs, which nobody really cared about in the past, but now with IBM specifically coming to play, a bunch of other companies, they provide all the sensors, they send their own data science team to create these algorithms for you. But if you can build that talent in-house and do it yourself, you're ahead of the curve by a big factor. So these are a couple of the challenges in supply chain which we face. I'm sure you guys are facing different type of challenges. But I highly encourage you guys to go out there, figure out with the challenge you're facing, what sort of information you have about it. And are you currently capturing that information? If you are, who's working with that information? In what ways it could be used? Sometimes it makes sense to bring someone who has this knowledge to come in and guide you guys. But then again, it's always possible to build that talent in-house. I think I want you guys to leave this session with one thing in mind, that if you're sitting at the top level of your organization and you feel like there's a challenge that constantly bugs you guys and costs you a bunch of money, think about building a talent in terms of the data side and put that to work. The amount of benefit you get is just speechless. So up until this far, by the way, did you have any questions? Just raise your hand if you had any question, if you wanted to share something specific in regards to your industry. Any question? No comments?
I wanted to ask about you mentioned Python and another
RStudio.
Yeah, so tell us a little bit about what
I'll get to that part as I go.
Okay.
That's towards the end of the presentation. We're not that far. I think we're halfway done. I wanted to talk less and have you guys ask more. So this is actually from a book I was reading last year when I got into all this stuff. These are different ways of using your data, different approaches or different analytical approaches to use the data. It starts at the bottom from descriptive, go to diagnostics, predictive, and prescriptive. This, I think most of the companies are working at this level. I mean, this is basically providing a report to your leadership team to say how much was the sales last year, how much product we sold, things like that. Pretty, basic stuff. It's basically like looking at the rear view of your mirror of your car, and doesn't tell you anything about the future. It's all about the past. And you can do it in Excel. You can do it in Tableau, whatever software you use. One step ahead of this, and that's what I'm gonna get down, talk more in the next slides, is when you focus on one specific issue and you said, what happened? Why did we miss this load? And it's one of those things that, how many people are familiar with SQL language, by the way? Perfect. So there's a lot of time you say, hey, what happened? Why did we miss this? And one of your analysts probably goes to the database, write a query, and find out that, oh, it's because you were out of raw material. So it's just a short solution. You're going at a specific topic and you want the answer right there. It's a little bit more advanced, but then again, doesn't tell you anything about the future. And then you get down to the predictive side, which is about, I know this happened in the past. I want to find out the patterns of this machine, the patterns of this demand, to be able to predict it from now on. And that's where most of the machine learning stuff comes into play, where you can either classify an issue or find a regression model to form it, or use neural networks to, if it's like an audio type of piece or a specific vision type of pictures, pixel-oriented type of data, you can model that, which comes in handy a lot of time. Especially in our case, the idea is that we could have paid over $200,000 to buy an inspection machine, or we could have built it in-house just by having a camera inside the tunnel to take pictures from the product. And based on the pictures, if we had the knowledge, we could have created those algorithms to predict if this is going to be a failure or this is going to be a success, which would save us a lot on the raw material, because there was no repair in our industry. Once it was a bad product, you tear the shrink film off, you put the products back on the line to get them packed again. So a lot of cool stuff there. And then with the prescriptive is when the recommendation comes in. It's when the cycle of act and react comes into play, where you figure out the process. Now you want the machine to do it. I don't want an operator sitting next to the machine to say, oh, I need to change this raw material. I want to have a robotic arm next to the machine that whenever that happens, the arm goes in, remove the bad material and replace it with the good material. That's where the prescriptive comes in. It's more about recommending the system what to do now that you can predict it, right? So this is at the highest level part. It takes a lot of companies years until they get to that point. And then this is just, same thing I repeated. So these are a dashboard made in Tableau software. For those of you who doesn't know, Tableau is an open resource type of application that you can go in there, dump your data, and beautify it in multiple ways and visualize it. It's pretty cool. You can share your results over HTML, that kind of saves the trouble of sharing Excel files and things like that. So I highly recommend you guys reading more about Tableau. It's easy to work, extremely easy to work. That's with the dashboarding, essentially looking into the past. With the ad hoc analysis is all those questions of why, like why did this happen, why did that happen? If you get to the point that you can't answer those whys, it tells you one thing, that you don't have the right data structure for your data streaming. That means that your people cannot go to a centralized database or a data lake or a data warehouse to find that information. So that's a trigger for you to say, I don't know why. I need to figure out, and for that I need to have a firm structure on the data. And it's one of those things that we had a lot of talks with the director of finance, IT, in terms of how much to spend on our data infrastructure. And the idea was that if we don't have the data, we don't know what we're doing. And it's not about matter of return on investment for the data. It's almost like the blood in your system. If you don't have it, you don't exist. Like I can't come up with a concept to show you there's a return on investment for this unless if you invest in it. And usually companies that start at the smallest scale, pick one segment, collect the data into the either warehouse, which is more structured, or a data lake, which has all sorts of data in there, like vision data, audio data, things like that. And from there, they start working their way up. And that answers all these questions of why. One of those they want one answer, you can find that one answer using SQL queries and things like that. With the predictive, I'm a huge UFC fan, but the idea was that like being able to predict anything. And nowadays, I know they're doing this on basketball games and things like that. If you think about it, every player has some sort of input and an output. If we're talking about football, the output is the receiver being able to catch the ball. If they catch the ball, it's a 1. If they don't, it's a 0. So if I have this player and the quarterback playing together for like a day and I collect the data, I can know the angle of the throwing of the quarterback, the spinning, the speed of the ball, all those parameters. I should be able to predict what it takes to make a good catch, right? So with that, I can pretty much simulate the entire game in a way, right? So that's what I know with NBA, they're using a lot of this data because with the court of the NBA is a little bit smaller, they're able to locate all the players throughout the entire game and see their movements inside the game, and they can figure out a lot of cool insight in regards to why this team led the game by 40 points, 30 points, just because of different patterns they were playing, which is extremely cool. And either you have a classification issues, which is a win or lose, missile deliver, or click or no click. For us in manufacturing, I'll give you a specific example I was working on. It was in regards to when we have these packs of water, we put them on a pallet, and every pallet needs to be wrapped with a stretch film wrap before we send it out the door. And we realized that we're putting too much of those shrink film material on the pallet, stretch wraps on the pallet. And that cost us extra $3 million per year across all the plants, because we didn't know what's the right amount of film that we can put on the pallet. So they came in, they said, not only you go out there and figure out what machine learning is, also go figure out how we can fix this issue using machine learning. So for us, and when I got down to the issue, I realized there's a couple of different outputs. They want to reduce the ground weight, which is a regression issue. They want to eliminate film breakage, because if you stretch the stretch film too tight, then it's going to break at some point. Every time it breaks, it requires an operator to go in there, retread the entire film, and it takes some time from the operation. And they didn't want that. And they said, hey, there's also a third objective, that every pallet within the warehouse for transportation needs to be able to maintain a specific amount of force. If it doesn't, the pallets will fall over, either in transportation or when you double stack the product in warehouse, they might lean and over time cause safety issues. So in a way, I had 3 objectives, and one of them was the film breakage, which was more or less like a classification issues. I knew my process parameter. I knew how much tension we put on the film. There was an arm that would wrap the film, and I had the speed of that arm, a lot of cool data. So I created a classification algorithm for that issue. And then there was a regression issue with what sort of parameters should I need to set up on this machine to give me exactly 180 grams of film. And I would figure that out with the regression, feed those parameters into my classification. The classification would tell you whether or not that film is going to fail. That was something cool we came up with IBM, and it saves us tons of money. Just being able to eliminate those touch points of operators or mechanics to go in there and change these process parameters save us a lot of time as well as line downtimes. So this is with the predicting of this stuff. And then the next step is always about, and with the prediction, by the way, this is what I'm going to explain from the really high perspective, and then if you guys want, we can dive into detail. But essentially, the way we predict this stuff is that we have a source of data, and from that source of data, we take a data set out, and using that data set, we're going to break it down into 2 components. One of them is called the training set, the other is called a test set. So the idea is that I'm going to train my model on a training set, and then once the model is built, I'm going to test it with a test set, right? And then if the results comes in positive and I have high accuracies for my models, then I can send that model into production. And over time, maybe you put in time frames of every month, every 2 months, every week to reevaluate that metric, that model performance based on the existing data. So once I have the model, I'm going to feed it into my prediction environment. These are the input data. These are the live data coming in. And these are the output that my model is predicting. If my model predicts 60% of the times, the film's going to break, which is a good thing, that's good, but 60% is too low. So I want something more closer to 85 or 90%. So over time, you keep working on this model, and you perfect it, and you perfect it. So this is kind of like a beginning to an end of a data science project, but takes a lot of effort and things to, from here to first clean the data. Cleaning of the data takes a lot of time. And once the data is clean, now you want to work with someone to understand the process. And for manufacturing, it's way harder because you need to understand how the machine itself works. Like, what are the parameters on the machine? What is the ampere? What's the voltage on the machine? So you have to be a mechanic as well as a data science, which is really cool. And that's essentially how the prediction side of things works. So you have training set, and then you have a test set. And then the idea is that sometimes you might overfit your model. What it means is that, imagine I have a set of data. I'm going to build a model based on those set of data. For testing it, I'm going to use the same set of data to test it. Obviously, the results are 100% accurate, right? So you're overfitting it. Sometimes there's underfitting, where something with your sample was wrong and you weren't able to capture the right parameters, and that's why you underfit it. But these are the stuff that that data scientist person or data analyst person need to be exposed and work with a lot of cool different coding platforms and things like that to figure this stuff out. This is not something you can do easy on Excel. And that's why, like in terms of even benefits and salary, most of these data science people get paid way more than a simple data analyst, because of all those programming and statistic knowledge they have. So before I move on from the prediction side, did you guys have any question? By show of hands? No? All right, okay. So the last part is about recommendation. Like I told you guys, with the Industry 4.0, we were here. Like, we managed to find a machine that does the job faster. And now, with the recommendation thing is that, now that I know how the process works, can I translate it back to the machine and say, if this happens, do this. If this happens, do that. So that's where the recommendation parts come in. For manufacturing, it's different than IT. Like Netflix, recommendation system for Netflix is entirely different because it's based on rankings of the users. But manufacturing ranking doesn't have a meaning. Like ranking in terms of performance might have a meaning. So what I mean by that is that a ranking of a raw material might be better in terms of more line uptime, right? If a specific type of raw material is causing way more downtime, then it has a lower ranking. And when you're recommending the next highest performance to the machine. And these are all possible when you have an automation team, when you have a data team, because then the automation team gotta have to go out there, find a robotic arm, something to replace that specific raw material, if that's what we're talking about. So that's where the recommendation portion comes in. It's essentially kind of writes over your models, which is extremely cool. So this is kind of like an A to Z of data science, super fast. Don't want to bore you guys, you all might be already tired. But this is the 1 to 4, and then there's, if you look at Netflix and Amazon, the way they build the recommendation models, essentially work this way. They have something called clustering techniques, which they cluster people into different groups. Group of people that first bought the book and then were enticed to also buy a pack of water. So that's one cluster. And if you buy a book, Amazon knows the probability that you're going to go and buy that pack of water. So that's how they advertise everything around your website or app that you're using. And that's why we don't know this. I mean, with Facebook, the recent incidents with Facebook, a lot of these came to light that everything you do on social media is almost like leaving a track behind about your personality, your beliefs, everything you think about. And people can use it. I mean, they use it back in the election in a way, the Twitter data, they knew what a specific words would trigger the people, would trigger people to like a Twitter more. And they would use those specific type of words or a statement more in their rally talks and things like that. So that's the use of social media, and that's how other companies are using it. Last week there was a seminar in USC, it's called Big Data Day LA, which I highly encourage you guys to attend next year's session. But Warner Brothers was talking about the fact that they don't even make a movie without having the data on the users. So even in the future, the lines, the script of the movies are written in a way that would trigger a specific type of people. So in the past, the writers would just write based on their intuition, but that might be gone, 5, 6 years from now, which is crazy. They already showed 2 different trailers for the same movie. One of them was made using the data they had on the user, and one of them was just an organic type of trailer. And the one that was made by machine learning recommendation got, I think, 5 million views. The other one only got 500,000 views, which showed how much different data would generate in your business. We're almost towards the end. Yeah, so with the data, every time I think about it, I think of Jeff Bezos. There was a video to this. If you could provide the slides to the team, that would be great. They can watch the video later on. But why is it that everybody's afraid of Amazon? They can walk into any business and take over any business in a heartbeat. So it's easy. It's way easier than you think. For us, we constantly, this is one of my talks with my senior manager, and one of the reasons I left, I thought that manufacturing is not as adaptive to all these technologies and these different what do you say, disruptors of the business. And for us, I always brought that up, that what if Amazon decide to get into this business and make water in a different type of package, and all of our machineries, God knows how many of them we have, only works with plastics. So if the raw material changes, we're screwed. What do you want to do? It's easy for a CEO probably going to sell it out to Coke or Pepsi or any of those companies, but what are you honestly going to do? And that's where Amazon comes into play. They're like, we already know everything about the consumers of that product, and we're going to steal your talent. I don't need to train a mechanic or something like that. I'm going to hire your people, and they're going to work for me. So at the end of the day, maybe Amazon could be that one single source of everything in the future. You need everything, you just call Amazon. Everything is owned by Amazon. It's not far from reality. And the idea is that who has the most data has the most power. And that's why nowadays, if you're not tracking the data, Amazon will come in and steal it from you. For us, they even came to us to make them water. Most of their waters, I think Niagara is making their water, but it's only a matter of time before they have enough information to get into that business sector. If they feel like there's a value in it, they will get into it. And that's essentially the end value of this. Maybe the word of future is just word a bunch of data scientists working, honestly, and you have the machine do the rest of the thing. But that could be possible. So tools, some of you asked about this. How much time do I have left? 50 minutes.
Let me ask a question.
Yeah.
There's a term that we use in the APICS body of knowledge called automation. Are you familiar with that?
I think I've heard about
What
it.
it means basically is the machine adjusts itself to stay within the control limits of the process.
Yeah.
Is that what this is all about?
It could be used in that format as well. It could be used, because in a way you're telling the machine that these are my upper limit and lower control limits.
Right.
And like back in the days, an operator had to be there to change stuff to make sure you're within.
Yeah.
But nowadays, it's talking about body of Six Sigma. With that type of approach, you can maybe manage to achieve like a 4 Sigma. But with this approach, you can easily go for a 6 Sigma.
Yeah.
And everything's done by the machine.
I mean, if you watch an old-time lathe operator, they'd stop a process and then cap the thing and bring it back in, and then I mean, it just seems obvious that you could do it.
Yeah, it's not undoable for humans. It just takes a lot of time, and you don't have the capacity to digest all that information, because a lot of our mechanics knew things from it was like an intuitional type of thing. It wasn't that they looked at every single parameter on the machine. They just knew that temperature and humidity plays a major factor. Let's just change this to for now. And I think we had the lightest bottle. Yeah, we had the light. We still have the. I still say have. I'm not with them anymore. But we had the lightest bottles in the industry, and I think every 0.1 gram of plastic, less plastic we put into the bottle, overall would generate something around at least like $50 million of savings in raw materials per year. That was just by 0.1 gram of the plastic. And if we manage to do that on every single raw material, think about how much savings we have. So tools and stuff, these are the last slides. These are the stuff I use, but I encourage you guys to explore internet more. The languages people use are mostly Python, and Jupyter Notebook is one of the famous platforms to code. You can code in SQL, RStudio, whatever is your forte in terms of programming, you can program on Jupyter. Which Jupyter pretty much is, think about Excel in a way that you have a view of the data sheet and everything. You can have the same thing in Jupyter, but you just have to code it. And then the way we collect the big data is a little bit different than traditional SQL-based type of databases. The new ones are called data lake, where you just dump everything in there with no structure, and the user will define the structure upon retrieving it. So they use Hadoop, or they use a Spark to store the information, and then even for processing that information, you can use Hadoop. They use a Spark, which is a programming language, works on top of your data lake to be able to do a lot of those machine learnings at a big scale. And then, You can use Plot, Elvi, or Tableau right here for data visualization. There's a lot of businesses on selling cloud, and cloud is essentially the beginning of all this stuff. Unless you set your stuff on the cloud, it's so hard to send it to different places. And Google Cloud definitely is one of the big ones. Amazon AWS is another one. And TensorFlow is specifically designed for machine learning algorithms at the big scale. So that's again a different type of language, programming language. This is in terms of tools, and this last one is in terms of training. If you're interested, these are the resources I want to train on. Nobody really paid a dime for my training, so I had to find the best free trainings I could, and I received it from all these resources. They have a lot of free courses, or courses as high as like 20 bucks, 30 bucks, which was affordable. So definitely try all of these, or a combination of these, whichever works best for you. If your statistics background is strong, spend more time on the coding side. If your coding is strong, just take a couple of stats courses, linear algebra courses, things like that, because it's going to help you a lot when it gets to deep learning and more complex algorithm type of things. Yeah, so that's pretty much in terms of the training. So with that, I think I'm going to end my presentation and turn it back to you guys. So feel free to bombard me by any question you have.
I have a question. So,
Sure.
how does this go into, or how does AI apply to machine learning? Can we use AI to use?
So AI and machine learning goes hand in hand. AI is essentially deep learning. There's machine learning and deep learning. The idea is that you have two types of training. You either have supervised learning or unsupervised learning. With supervised learning, you give the model an input that you already knew the results. Like you knew the machine failed at 3 p.m. yesterday, and that your model is going to predict that. With unsupervised, the machine doesn't have any way of knowing whether this is a picture of a dog or a cat. But based on processing a lot of different pictures of dog and cats, it will recognize the common patterns. It doesn't know it's a dog, but it knows that all these pictures are essentially representing the same thing. And that's where the AI comes in. And the AI is more on the deep learning side. Hope that answers.
So you can't get into, basically you can't use AI to start using machine learning, right?
No, definitely start with machine learning first, because AI is a little bit more advanced and requires more like algebra and statistics to get into. Yeah, but machine learning is way easier. It starts with regression. I mean, we all at least have done one linear regression sometimes in our life, right? So it's way easier to start that way. Any question? Any other question, guys? No?
Well, in terms of how do you, okay, so let's say if I have a bunch of data, right, or what's the starting point? You say, let's say a small company. What's a good starting point if you want to improve a process? What do you do?
So it's definitely one of those things that you need to look at the needs of the business, right? Because I can have 1,000 different cool ideas, but if the business doesn't see value in it, it's just pointless, right? So you find that area. Now that you found that area, now you go in terms of asking, do we have information on this segment or we don't? If we don't, let's start building something. Especially with these cloud services, they charge you based on your usage. They're extremely cheap comparing to like having an actual server in-house to serve all the data, house all the data. So start with that, get it on the cloud, do something, if you have it in an Excel sheet, work with that. Generate some sort of result with Excel sheet at the descriptive format. Ask yourself, do I have a dashboard of knowing what happened last month? If you don't have that, start from there. And then at the point you realize that my data is getting out of hand, Excel sheets are not capable of housing it, then you can move on to either having a data warehouse, like an Oracle type of warehouse or SQL-based database, or at the highest level at the cloud database. But this is how it works, essentially. But it has to be one of those things that they say in change management and things like that. Someone has to start that way. And unless there's a group of people pushing for it, no one's going to ask for it.
Have you had much experience of sets of data. Like in the logistics at Amgen, we're global logistics, so we have several different software programs that don't talk to each other, several different data sets, like the logistics providers, all the single LSPs and TSPs out there don't connect it to our system, but they carry a lot of our data points. So there's an integration
that's where
problem.
that's where the idea of data lake comes into play. You have a lot of information sitting on different places. You want to bring them all together in one place, and then
be able to search the data in a logical way.
So there's two ways of going about it. You either have SQL-based databases, they're already a structure. Someone's sitting on the back end and making sure everything goes in there is structured. But with the data lake, there's no structure. They just literally dump everything in there, and it's based on the user to define that structure, to say my unique identifier on the transportation table is this, and on the supply chain table is this, so I want to join them together, right? But it's definitely one of those things that the idea of having a cloud database becomes really handy. It becomes way easier to have everything in one place, and can give you a lot of full visibility into issues you've never seen before.
And then it's like trying to convince them to do it. But also stuff like risk aversion through geopolitical data or just unknown holidays internationally. Like there's certain risk aversion that you can utilize if you have all that, if you can draw it together somehow.
And there's a lot of open source data that you don't have to spend a dime for it. Like temperature data already free, Yahoo provided. It's an API you connect to it.
In a big corporation trying to use open source?
No, it's nothing like confidential. It's just a temperature you're pulling in. But the idea is that you can use either access to manually pull everything together and show the results. And if access works, you can say, hey, I can do this at 10 times the scale if I had it on a data lake or a cloud database somewhere. So that's definitely what I suggest. That's what we were doing in Niagara. Our systems were housing data on multiple different databases, and we were trying to work with Google Cloud and Amazon AWS. And those guys already know everything. They come in, they already know your system, if it's Oracle-based or SAP-based, and they just pull the data out into one place for you. So one of those things vendors come in.
I think it's SmartLogic or something from Google. SmartLogic or something.
I don't know, I've never heard of it, but it could be. Well, Google has a manufacturing segment. If you're interested, you can call them up. They send out consultants. They do an amazing job. Sure.
I have a question.
Yes.
So you're not working at that company anymore, right?
No, I don't.
So what are you doing now?
So I'm a senior data analyst right now. I work for this company called Verus Analytics, and essentially what we do is without getting into the confidential part of things, but we audit a lot of companies requested by the federal government or state government using the data. So that's my job, is to essentially sit down, clean all these data, figure out common patterns and things like that to figure out whether or not they're lying to the government or not. Yeah. Bad for them, good for me.
Would you recommend? Sorry. Would you recommend any other like readings or materials or podcasts, anything to that effect, aside from the self-learning tools that you displayed?
So as far as reading, there's this book. I'll send you the link. It's an online book. It's about, so when Facebook got into this stuff, it was back in 2007, and we're just talking about it in 2018, which is funny. But and the guy who actually started the entire initiative at Facebook published a book. I can't remember the exact title of the book, but I'll send the link to Steven and he can share it with you guys. That book opened my eyes to this entire thing and gave me a path in terms of what to learn. So I highly recommend that. And then participating in a lot of meetups. When I initially got into it, nobody really told me what to learn and how to learn it. So I went on the Meetup app, just download the app and punch in data science, and a bunch of these meetups come in, and most of them are for free. You can just go in, sit in there, instructor come in, walks you through a coding session, and that's how I learned most of the thing I know right now.
That's great, thank you.
Sure.
What about EDX?
EDX is amazing. I'm taking a course right now from UC Berkeley. And most of courses are free unless if you want a certificate, but I don't want a certificate, I just want there, so I go for a free version. Yeah, ethics is definitely good. I don't know, yeah, all of these websites, this last one, if I could go
Can you
to
post this in?
full
I'll
screen.
get that for you.
So this one is called Kaggle. So Kaggle is like a community for people who code, basically. And most of these people, this is the beauty of this community, online community. Everybody's willing to share their knowledge. And on Kaggle, people share everything they know for free. They're like, hey, I figured out the cool way to build a recommendation model. Here's my code. Call me if you have a question. So that's how people get matched up. So I highly recommend Kaggle.
So R is completely different to Tableau, right? Tableau sort of does all the R language for you.
Yeah, Tableau is like a SQL-based visualization tool. So it's almost as if you were writing in SQL, but you're just dragging and dropping things without writing
So you don't
any
have to
code.
learn like R language or?
No, no language required. With Tableau is so easy. You just drag and drop and it does everything for you.
And I got the impression that with some of the predictive analytic models that you don't have to have 100% clean data, that it kind of allows you to rise above.
You
some
never
of that.
have clean data. You have no, I probably, if I want to break
Because
it
if you're
down,
using the test and the training set, right, you should
Yeah.
be able to have unclean data and still get a
before building your model, you need to make sure it's clean. And that's where 80% of the effort goes into.
for the
making-
training set.
To pick the training set, you need to make sure the training set is clean.
Training set is
Otherwise,
clean.
you're just feeding garbage to the model and,
Okay.
and it's gonna deviate its accuracy. Yeah. That's where it takes a lot of time to
Because
pick.
I had heard that you could rise above it, but that's how you do it. You make sure the training set
Yeah,
is clean.
yeah.
Then you can rise above it.
Exactly. It's like, it's a supervised learning. It's almost like when you're teaching your kids that don't touch a hot thing, what you do is that, like, especially when they're a kid, you like get your hands close to the glass or whatever it is and you say, ooh, you know, it's hot, and that's you teaching the kid that it's hot. But if your data is not clear, you might extend your hand but doesn't provide any reaction, so it doesn't know what to do now.
Gotcha.
Yeah. All right, thank you guys, appreciate it.
And on behalf of APICS-SFV Valley, give it a
Dude, thank you so much,
Thank you,
I
man.
appreciate it.
Thank you for having me.
Right.